So if you look at here, 8051 family, the ROM size is 4 KB on-chip ROM, and it is having 128 bytes of random access memory. This must be a data memory, and this must be a programmable memory, program memory and data memory. This is internal program memory, internal data memory. And this 8051 has got two timers for delay purposes, and all these timers will be very helpful in industry oriented delay. In that context and all, these timers are mostly effective. Then coming on to input output pins, if you look at this input output pins, it is 32 input output pins are there. That is, it is having nearly 4 input output ports in 8051. Then it is having 1 serial port. These are all parallel port. These 4 input output ports are parallel port, which is comprising of 32 pins, and we have 1 serial port, parallel port 4 and 1 serial port, and we have 6 interrupt. So if you look at this 51 microcontroller, it started and developed in the year 1981, and it is an 8-bit microcontroller. So the data lines are 8 data lines and 16 address lines. That is D0 to D7 is 8 data line, and A0 to A15, which is the 16 address lines. So this is the internal block structure related with 8051. So as I told you, it has got 4 KB internal programmable memory and 256 bytes of data memory, that is the random access memory, and we have 2 timers for delay as well as for counting purposes. Then we have 4 input output ports. These are all parallel ports, and we have 1 serial port. Along with that, we have the clock and the 6 external interrupts. So this comprises the full microprocessor block structure. So the features are being listed here. It is having 8-bit CPU, on-chip clock oscillator, 4 KB program memory, that is the ROM, and 128 bytes of data memory, which is the RAM. And this 8051 can able to access 64 KB of external program memory. Actually, this is internal program memory, 4 KB, whereas this 8051 can access 64 KB of external program memory. Similarly, 64 KB of external data memory. Whereas here internal data memory is 128 bytes inside the chip, whereas the external data memory can lead up to 64 KB, as well as the external program memory also can cost up to 64 KB. As I told you, it is having 4 input output ports. So for every port we have 8 pins. For port 0 we have 8 pins, port 1 it is 8 pins, and port 2 it is 8 pins, port 3 it is 8 pins. So all these pins alone, it is given as 32 input output pins, but the ports, if I say as a port, it is 4 input output ports. So while we are discussing the features itself, I shown you it is 2 timers we have and 1 serial port, and that serial port is this UART, Universal Asynchronous Receiver Transmitter, and 6 sources of interrupt, which is interrupt 0, timer interrupt, and external interrupt 1 and timer interrupt 1, as well as serial communication interrupt and timer interrupt 2. So external interrupts are 2 here, whereas these are all mostly the timer interrupts and serial communication interrupt we have. And the general purpose registers R0 to R7 we have, but this R0 to R7 is made of 4 different R0 to R7, that is in different banks. Nearly 4 banks of R0 to R7 is present. That is what here. It is 4 banks of R0 to R7. Bank 0 will have one R0 to R7, as well as bank 1 will have R0 to R7. Similarly, bank 2 and bank 3. So 4 different banks of R0 and R7 will be there. Coming on to the pin diagram of 8051, it is a 40 pin IC. It is a 40 pin integrated circuit, which comprises the VCC and ground and 4 different ports. So if you look at here, so this is port 0, which is having some 8 pins, and this is port 1, which is exclusively for input output only, whereas port 0 will function for external memory access. Similarly, port 2 also will be used for external access of memory, whereas port 3 is for the serial communications, timer, interrupts, read and write signals. Whereas port 1 is exclusively for input output purposes. So if you learn based on the 4 ports, the total 32 pins is over. Remaining, we have one program strobe enable. Whenever if the 8051 is accessing the program memory, it will be this program strobe enable will be a low active signal, because it is a low active signal. It is a bar, PSEN bar it is, so low active signal. Then another pin, it is for ALE to make that demultiplexing of address data line, because here also address and data lines are multiplexed, as we saw in 8086 also. The address and data are multiplexed. Here also the data and address lines are multiplexed. So demultiplex this, we need this ALE signal. Similarly, external access, for accessing the external memory, whenever if 8051 is not using the internal memory and make use of external memory, this EA will be a low active signal. It is also a low active signal. So other than that, it is all simple pins only. So the 4 IO ports, if you keep in your mind, the remaining pins easily you can denote it. So 4 pins in the sense, it is port 0, which is also used for external memory access. Similarly, port 2, which is also used for accessing external memory. Then we have port 1, which is exclusively for input output, and port 3, which is for the serial port and interrupt process. So EA stands for external access. Whenever 8051 makes use of external program memory, this EA bar, EA will be in 0. So if it is 0, whereas EA is equal to 1, then it is accessing internal memory. If EA is 1, then it is accessing internal memory. So port 3, if you look at port 3, it is a special case here. 2 pins are used for serial port purposes, receive data and transmit data, whereas the second 2 pins are used for external interrupts, interrupt 0 and interrupt 1, whereas the third the 2 pins are used for timers T0 and T1, whereas the fourth 2 pins are used for the read signal and write signals. Whenever if it is external memory is used, these read and write signals will be utilized for accessing the external memory. So this is the architecture of 8051. So whatever blocks we have come across, nearly 4 input output ports. If you look at here, we have these 4 input output ports: port 0, port 1, port 2 and port 3. This port 0 will have a latch as well as driver, so latch, a driver. Port 2 will have a latch as driver, latch and driver. Port 1, latch and driver. Port 3, latch and driver. So all ports will have a latch for input and driver for output. Because it is an input output port, all the ports are input output ports. So for input, the ports might have a latch, whereas for output, it may have a driver. So for that alone, we have these 4 plus 4, it is 8 blocks are there, 4 for latches and 4 for drivers. The next thing what we have is the ALU, which is the important part in 8051 ALU. So in ALU alone, arithmetic and logical operations are taking place, and whenever if any flags are introduced, it will be affected in the program status word. So in 8051, a PSW program status word is the flag register. So whenever if any carry exists, if any parity flag exists, if any auxiliary carry flag exists, that and all will be affected in this program status word. So the most important one is the accumulator, that is the general purpose registers we have in 8051 for storing some temporary values. Similarly for B register for temporary values to be stored. So these two values will be running into this ALU for addition, subtraction, or AND operation, XOR operation. All arithmetic and logical operations can be worked out using this ALU. This 8051 has got internal 4 KB ROM and 128 bytes of internal data RAM. So for the program memory we have a program address register. For the data memory we have a data memory register. It is program address register, data address register. This is a data memory, this is a program memory. Along with that we have a timer and control circuit to execute all the timing functions of these blocks, when to work with this ALU, when this PSW should be stored, when this port should act as input output port, when this memory should be stored with certain values, when the memory should be accessed by the process ALU. Likewise, all timing and control operations are handled by this timing and control. Then we have at the right side some important registers which are all buffer, program counter, incrementer, program counter, and data pointer. Data pointer is divided as DPH and DPL. Data pointer is for storing the output addresses. If you want to store that memory in the output, then we have to store that memory output addresses in this 16-bit data pointer. This is actually a 16-bit register. This program counter is also a 16-bit register, but remaining all are mostly 8-bit registers. So here we have the SFRs, the special function registers, which are being divided into interrupt 0, interrupt 1, timer 0, timer 1, serial port, something like that. We have here TMOD, timer mode, timer control, power control. Likewise we have some important blocks here, along with the stack pointer, which is also a 16-bit register. That's a 8-bit register, sorry, stack pointer is a 8-bit register.